So in this problem, it's a very interesting problem, very interesting application. One capacitor plate, see semicircular plates are there. One capacitor plate is fixed, and second plate is rotatable about the point O, about axis passing through the point O. And the second plate dielectric constant is K and thickness is T. So thickness of second plate T means the separation between the two plates is T. Is it clear? When you rotate it by an angle theta, slowly what is happening there? That dielectric material between the plates is varying. So when it varies, obviously the capacitance also varies. So in this interesting illustration application, the first point we should calculate is C equivalent. And when capacitance is varying, net capacitance or equivalent capacitance is varying, the energy stored between the plates of the capacitor also varies. So what is that variation? Also let us calculate delta U. And third point is, because the plate is getting rotated by an axis, about axis passing through the O, there is moment of force is acting about that axis. So that moment of force also we can calculate. We can use mechanics. The moment of force into angular displacement is nothing but delta U. For example, moment of force is tau and angular displacement is theta. For any angular displacement, it should be equal to change in energy. Okay, that is the moment of force. These three things we'll calculate. Let us see step by step process. The first one, calculation of equivalent capacitance. So initially the two plates are parallel, that is theta is equal to 0 degrees. Then what is the capacitance? Let us take it as C1 K epsilon naught, because the dielectric constant of the second plate is K epsilon naught. A, what is the A? Area of the plate. It is semicircular. So pi r square, r is the radius of the plate, pi r square by 2, and separation between them is how much? T. So this is the initial capacitance of the given semicircular plate capacitor. See here, when it is rotated by an angle theta, and of course across these two plates we connected a potential difference V. So after rotating it by an angle theta, we can assume it is a combination of two capacitors. One, see this part capacitor here, it has air between them, and the remaining part, and here this part of capacitor has dielectric constant K, but not complete area. Some of the area of the capacitor plate is in air. So by after rotating angle theta, two capacitors are there, they are connected in parallel. So let us take let us calculate C2. What is C2? The capacitor which has air as its dielectric medium between the plates. So further, when it is rotated by an angle theta, say it is radius r, if it is rotated by an angle theta, how much area will be get rotated? So what is the area of the plate? The area of the rotated plate, that that we need to calculate. What is the area of rotated part? Half into r into r5. And this information, just go through the 8th, 9th, 10th class books, you can understand it. So this is the area of the rotated circular plate part of r square 5. So the capacitance is epsilon naught A, that is of r square pi by the distance between the plates of the capacitor. So this is the capacitance of the capacitor, part of capacitor in which the plate is in air. So remaining, now we'll calculate capacitance of remaining part, because theta angle is rotated, remaining part capacitance we have to consider. So same again, concept is same. How much area is there, and K epsilon naught, what is the area, because this half r square pi is rotated, is rotated, and this part between them, air is the dielectric constant here, and remaining part is what? So remaining area is pi r square by 2 minus this rotated part value, that is r square theta by 2. So see, this is theta, and this is r phi. Here it is also theta because theta angle is taken here. Okay, so k epsilon naught pi r square by 2 minus r square theta by 2. This is the area of the plate, remaining part of the plate, divided by what is the distance, how much distance is it has, t only. So this is the C3, k epsilon naught pi minus theta by 2d is the capacitance of the remaining capacitor. So now we'll calculate the net capacitance, equivalent capacitance, because they are connected in parallel, it is equal to C2 plus C3. So let us calculate the potential energy part here. The initial potential energy is how much? Or simply initial energy, will write initial electrostatic potential energy or energy stored of CV square, that is initial one of C1 of C1 V square. So C1 value we calculated in the first case when two parallel plates or capacitor to two plates are parallel to each other. In that case, what is C1 that we calculated? Right. This is initial energy stored between the plates of the capacitor. Now, what is the final energy also? We'll calculate by substituting C equivalent. So this final energy is epsilon naught r square by 4t into v square into k pi plus theta into 1 minus k. So that C equivalent is substituted here. We got what is the change in potential energy. Will take delta U is equal to U initial minus U final will do. After substituting U initial and UF, you will get, so this first term we can cancel, and here minus epsilon naught r square v square theta into 1 minus k by 4t is remaining, that is delta U. So delta U is equal to minus, I implement minus to the k minus 1. We will have epsilon naught r square v square theta into k minus 1 by 4t. So the next case, next thing we should find is the moment of force. So here let us take tau is moment of force. So according to rotational mechanics, the tau theta is equal to change in energy. So if you substitute that delta U here and both sides we can cancel theta, the final the moment of force equation is epsilon naught r square v square into k minus 1 by 4t.